Hey everyone! My first video on this new channel was about the crank slider mechanism. The version that I tested there was quite big and honestly pretty rough. So I started thinking about how to make the mechanics a bit smaller and more refined. Today I want to show you what I came up with and test those ideas in this small lifter model you see here in the front. One thing I wanted to try this time was using real ball bearings in the Revolute joints of the mechanism. I recently got these 623 ball bearings. They have an inner diameter of just 3 millimeters, so they're much smaller than the popular 608 bearings. For these bearings, I designed this small eye part where the bearings can simply be press fitted. For the other link that connects at the joint, I added a 3 millimeter hole and a tiny raised ring around it. That little extrusion keeps the links from touching each other and ensures that this second link only contacts the inner ring of the bearing. Then I connected everything with an M3 bolt and nut. I know some people say you shouldn't run a threaded shaft through a bearing, but for me, fast prototyping is more important than long-term durability here. Now for the slider at the end, it's made up of several subcomponents. The middle part is the actual slider. And on one end, I left a small placeholder piece for whatever functional element I might add later. Because this whole part is fairly long, I couldn't use the same bolt and nut connection as before. Instead, I designed a hole for a threaded insert and pressed it in using my soldering iron. I actually used an insert that's slightly longer than the hole on purpose. That way, the part again only touches the inner ring of the bearing. Finally, I rounded the top edge using Onshape's fillet tool to make sure it doesn't rub against the outer ring. For the servo connection, I simply copied the geometry of the round servo horn, or rather the servo disc. For this little test, I used the Feetech STS3215 servo. This is actually part of a family of bus servos that come with different torque ratings. Unlike standard hobby servos, these bus servos have some nice extra features. They can be daisy-chained, which is super convenient for things like robotic arms. In fact, the STS3215 is one of the recommended servos for the open source LeRobot arm from Hugging Face. Communication happens over a serial bus, where each servo can be assigned a unique ID. In theory, you can have hundreds of them on the same line. As a driver, I used the serial bus servo driver board from Waveshare. It's definitely overkill for the single motor setup, but I wanted to test it for future more complex builds. The board can be connected either to an Arduino or directly via USB to a Raspberry Pi. In this case, I connected it straight to my Mac and controlled the servo using an open source Python package. I still wanted to show you the mechanism when it's assembled. So here you have the slider element with a threaded insert. Here you have the Revolute joint connecting the crank and the connecting rod. And here you have the crank already mounted on the servo disc. I still wanted to quickly show you the parts in Onshape. So here we have the crank, and as I mentioned before, it's simply copying the geometry of the servo disc. And here we have the connecting rod, and you can see it better here than in the video that there is this tiny extrusion, which I think helps with the bearings. And finally here we have the combination of slider and the guide, and you can see here whichever functional element we want to add. Then we have the actual slider element, which is held in place by the guide. And then on the other side, we have the connection to the connecting rod. And here is this little hole where I put the threaded insert. And you can also see that this part has been rounded with a fillet, again, in order not to touch the bearing. Okay, so let's power it up and see it in action. That's it for this short demonstration. As always, if you have any tips or suggestions, please let me know in the comments. Thanks for watching and see you next time.